Hello, my name is SARIH Muhammad Amin bin SARIH OTHMAN.
Hai, saya AHMAD IMRAN bin ALIAS.
My name is FIKRI bin ZUNA ADENI. Today we are going to discuss about triple integral in cylindrical coordinate, that is divergence theorem. Divergence theorem, or also known as Gauss theorem, which relates the flux of a vector field through a closed surface to the divergence of the field in the vector volume enclosed. We can evaluate surface integral, but it might tedious, so we need to apply divergence theorem for the flux integral over closed oriented surface. We let G be a solid with surface S oriented by outward unit normal if f xyz is equal to f xyz I plus g xyz j plus h xyz k, where f, g, and h has continuous first partial derivatives on some open set continuing g. Then the equation double integral f dot n ds is equal to triple integral g divergence of f dv. Calculate the integral using cylindrical coordinate. From this question, the region U is bounded by the parabola Z is equal to 4 minus x square minus y square by the cylinder x square plus y square is equal to 4 and the plane y equal to 0 and z equal to 0. We get the equation that z is equal to 4 minus x square minus y square, and at the plane y is equal to 0 and z is equal to 0. So we get the area bounded at U at this side, and we have the equation that x square plus y square is equal to 4 and at the plane y equal to 0. So we get half of this circle. From the graph that we have plot just now, we get the range of r, theta, and z. The range of r is 0 to 2, and the range of theta is 0 to pi, and the range of z is 0 to 4 minus r square. Then we have to change the rectangular coordinate to the cylindrical coordinate, that is x square plus y square is equal to r square, dx dy dz is equal to r dr d theta dz. From the question that we have, we can change this equation to cylindrical coordinate. So we have the square root of r square, we can cancel off square root and power of 2. So we have r multiplied by r, we have r square. So from this equation, we can integrate is with respect to rz. So we get this equation and we substitute the value into the z. We get 4 minus r square is multiplied by r square, and we substitute this r square into 4 minus r square. We get 4r square minus r the power of 4, and we integrate this with respective to r, and we get 4r cube divided by 3 minus r power of 5 divided by 5, the range limit 0 to 2. So we substitute the value 2 into r, we get 4 multiplied by 2 the power of 3 divided by 3 minus 2 the power of 5 divided by 5 d theta, and we get the value of from limit 0 to pi 64 divided by 15 d theta, and we integrate this with respective to theta, and we get 64 divided by 15 from limit 0 to theta, and we substitute the theta into the volume, and we get this answer.
Okay, next example is to applying the divergence theorem between the flux integral of closed surface. So the question states that we have to calculate the surface integral of the cylinder by given the equation x square plus y square equal to 1, and the vector function of f equal to x cube over 3 plus yz, y cube over 3 minus sin xz, and z minus x minus y. We know that double integral of f dot dn ds equal to triple integral of divergence f dv. From the equation given, x squared plus y squared equal to 1. So we can conclude that x and y equal to plus minus 1. Based on the diagram that has been drawn, we can find the value of theta, r, and z. The value of theta is from 0 to 2 pi, value of r from 0 to 1, and the value of z from 0 to 2. Okay, next we have to find the value of divergent f. Divergent f equal to differentiation of x cubed over 3 plus yz to the delta over delta s plus differentiation of y cubed over 3 minus sin xz to the delta over delta y and differentiation of z minus x minus y to the delta over delta z. Then we have to put the value of the divergent f equal to x squared plus y squared plus 1 to the equation given. So the equation will be integrate from 0 to pi, 0 to 1, 0 to 2, integrate of x squared plus y squared plus 1 times r to the dz dr d theta. So we have to integrate one by one from dz dr d theta until we get the answer. So after we calculate the equation, we get the answer equal to 3 pi.
Now, in engineering application, consider a long cylinder of length L and radius S that carry a volume charge density that is proportional to the distance from the axis S of the cylinder. Determine the electric field inside this cylinder Z equal to 1, given that rho inside a bracket S equal to Ks coulomb per meter cube. K equal to proportionality constant. From the question, we know that the radius equal to S, Z equal to 1, and the theta equal to 2 pi. If we draw in the 3D, it will be like this. Now to determine the electric field, we use a Gauss law formula, which is a integration of electric fields times the surface area equal to C enclosed over the epsilon naught. C enclosed will equal to integration of density dV equal to integration of K S times S dz d theta and ds. Now we took a triple integral, integrate 0 to S, 0 to 2 pi, 0 to 1, Ks times S dz d theta ds. Now we integrate to the z, we got the integration 0 to s, 0 to 2 pi, ks square d theta ds. And we to integrate to the theta, we get the integration of 0 to s, 2 pi k s square ds. Finally, we integrate to the s, we get a 2 over 3 pi k s cube. Now we get the C enclosed, we put back to the Gauss law formula, we get finally we get the 2 pi k s cube over 3 epsilon naught volt per meter cube. That is electric fields. Thank you.